Have you ever stopped to think about the air all around you? It's everywhere. It fills your lungs when you take a deep breath. It rustles the leaves on the trees. It even carries the smell of pizza from the kitchen to your nose. This invisible stuff we call air is part of something much, much bigger and way more important. It's our planet's atmosphere. Think of the atmosphere as a giant, cozy blanket wrapped all around the Earth. It's not a blanket made of wool or cotton, of course. It's a blanket made of a mixture of gases, mostly nitrogen and oxygen with a little bit of other stuff mixed in. This air blanket is what makes our planet the perfect place to live. It's pretty amazing, isn't it? This gigantic blanket of air isn't just one single layer. Oh no, science is much cooler than that. It's actually made up of 5 different layers, stacked on top of each other like a giant invisible layer cake. Each layer has its own special job and its own unique personality. Some are warm, some are cold, some are busy with weather, some are way out at the edge of space. We're going to take a journey up, up, up through these layers, from the ground all the way to the final frontier. We'll see where airplanes fly, where meteors burn up, and where the beautiful northern lights dance in the sky. It's a trip you can take without ever leaving your chair. Our first stop is the layer closest to home. It's called the troposphere. The word tropos means to turn or to change. That's the perfect name. It's always changing. This is where all our weather happens. Fluffy white clouds, big gray storm clouds, rain, snow, wind that flies your kite. This layer starts at the ground, where you're standing right now. It extends up about 6 to 10 miles. That's about 10 to 16 kilometers. It might not sound like much compared to the whole planet, but almost all of the air in the entire atmosphere is packed into this one layer. This is the layer for life. We live our entire lives in the troposphere. Every person, every animal, every tree, every blade of grass. Why? Because the air here is just right for breathing. It has the perfect amount of oxygen our bodies need. When you climb a very tall mountain like Mount Everest, the air gets thinner. It becomes harder to breathe. Most airplanes fly in the upper troposphere, especially the ones that carry people from city to city. Have you noticed it gets colder as you go up a mountain? That's a key feature of the troposphere. This happens because the ground absorbs heat from the sun. The ground warms the air closest to it. This temperature change helps create weather. Warm air rises, it cools down, then it sinks again. This movement is what we feel as wind. This movement is what forms clouds. Look up at a cloud. Feel the wind on your face. Take a deep breath of fresh air. Hey, that's the troposphere doing its thing. Let's climb higher, past the clouds and the airplanes, to the second layer of our atmosphere. The stratosphere. The stratosphere starts where the troposphere ends. 31 miles, 50 kilometers up. The air here is much, much thinner than in the troposphere. If you were here, you wouldn't be able to breathe. It's also very calm. The word strato means layer, and the air in the stratosphere is layered and stable. There are no storms or turbulence here, so spy planes and weather balloons can get a smooth, steady ride. Now, the stratosphere has a very, very important job. It contains a special kind of oxygen molecule called ozone. You might have heard of the ozone layer. Well, this is it. The ozone layer is like a giant invisible pair of sunglasses for our entire planet. The sun sends out powerful energy, including harmful ultraviolet or UV rays. Too much UV radiation can cause sunburns, damage our skin, and harm plants and animals. The ozone layer acts as a shield, absorbing most of these dangerous UV rays before they can ever reach us down on the ground. Without the ozone layer in the stratosphere, life on Earth's surface would be very difficult, if not impossible. In the stratosphere, it actually gets warmer as you go higher. What? Warmer? Yes, remember how the ozone layer absorbs energy from the sun? That absorption releases heat. So, at the bottom it's very cold, maybe minus 60 degrees Fahrenheit, minus 51 Celsius. So, while we can't live in the stratosphere, we absolutely depend on it. It's our planet's built-in sunscreen. Every time you go outside on a sunny day without getting instantly fried to a crisp, you have the stratosphere and its amazing ozone layer to thank. Continuing our journey upward, we now enter the third layer, the mesosphere. The word meso means middle, and this is the middle layer of our 5-layer atmospheric cake. The mesosphere starts right above the stratosphere at about 31 miles, 50 kilometers, and stretches up to about 53 miles, 85 kilometers above the Earth. The air here is incredibly thin, about 1,000 times thinner than the air we breathe at sea level. If you could stick your hand out into the mesosphere, you wouldn't even feel the air molecules because they are so far apart. This layer is the coldest place in Earth's entire atmosphere. Brrr! As you climb higher through the mesosphere, the temperature drops dramatically. At the very top of this layer, Temperatures can plummet to an astonishing -130 degrees Fahrenheit, -90 degrees Celsius. That is far, far colder than any place on Earth's surface, even the South Pole in the middle of winter. Despite being so cold and empty, the mesosphere has a super important and frankly super cool job. It acts as our planet's cosmic shooting gallery shield. Every day millions of small pieces of rock and dust from space called meteoroids hurtle towards Earth at incredible speeds. When these meteoroids hit the molecules in the mesosphere, the friction is so intense that they heat up and vaporize in a brilliant flash of light. From the ground, we see these flashes as shooting stars. So the next time you make a wish on a shooting star, you're actually watching a tiny piece of space rock burning up in the mesosphere, protecting us from being bombarded. So the mesosphere might be the coldest and one of the least explored layers of our atmosphere, but it's a true hero. It silently stands guard, incinerating countless space invaders before they can reach the ground. Scientists also study this layer to see strange, wispy clouds called noctilucent clouds, night-shining clouds, which are made of ice crystals and are only visible at twilight. The mesosphere is a mysterious, freezing cold and protective shield that makes our planet a safer place to be. Get ready to feel the heat as we rocket into our fourth layer, the thermosphere. The word thermo means heat, and this layer definitely lives up to its name. The thermosphere begins above the mesosphere at about 53 miles, 85 kilometers, and extends all the way up to around 375 miles, 600 kilometers, or even more. This layer is very, very hot. Temperatures can soar to 2,700 degrees Fahrenheit, 1,500 degrees Celsius, or even higher. That's hotter than a baker's oven. It's hard to imagine a place so high up being so incredibly hot, but it's true. If it's so hot, would I feel like I'm burning up? The answer is no, you wouldn't. It's a strange paradox. Temperature measures how fast particles move, and the few particles in the thermosphere zip around at incredible speeds, which is why the temperature reads so high. However, the air is extremely, extremely thin, practically a vacuum. Particles are so far apart they don't transfer much heat. You wouldn't feel hot, you'd feel the freezing cold of space because there aren't enough particles to bump into you and warm you up. The thermosphere is where some of the most beautiful sights in the sky happen. This is the home of the aurora borealis, the northern lights. This is also the home of the aurora australis, the southern lights. These shows are created when energetic particles from the sun, carried by the solar wind, collide with gas particles in our thermosphere. Collisions excite the gas and cause it to glow in brilliant colors like a giant cosmic neon sign. Green and pink lights come from oxygen, blue and purple lights come from nitrogen. This layer is also very useful for people on Earth. The International Space Station orbits here. Many other satellites orbit here too. Because the air is so thin, they can travel at high speeds with very little drag. This layer plays a role in radio communication. Certain parts, called the ionosphere, can reflect radio waves, allowing radio signals to travel long distances around the curve of the Earth. We've reached the very top floor of our atmospheric skyscraper, the exosphere. The word exo means outside, and this is the final frontier where our atmosphere gradually fades away into the blackness of outer space. The exosphere begins at the top of the thermosphere, around 375 miles, about 600 kilometers, up, and continues outward for thousands of miles. There is no clear-cut end to the exosphere. It just gets thinner and thinner and thinner until it merges with the vast emptiness between the planets. It's the last whisper of our planet's air. The exosphere is less like a layer and more like a fringe. The air here is so incredibly thin that molecules of gas can travel for hundreds of miles without bumping into one another. The main gases you'll find here are the lightest ones, like hydrogen and helium, which have floated up from the layers below. Some of these particles are moving so fast that they can escape Earth's gravity altogether and drift off into space forever. It's like a slow, constant leak from the very top of our atmosphere. It's Earth's way of saying a long, slow goodbye to its outermost air particles. Life in the exosphere is pretty much just satellites. This is a great place to park certain types of weather satellites and communications satellites because they can orbit the Earth from a very high vantage point. They are so far away that they are well and truly in the realm of space. There's no weather, no sound, virtually no air. It's the silent, empty region that separates our world from the rest of the solar system. It's the boundary that astronauts cross when they leave Earth on missions to the Moon or Mars. They pass through the exosphere on their way out into the great beyond. Now that we've journeyed through all 5 layers, let's step back and appreciate how much our atmosphere does every single day. It's not just one thing, it's a whole team of features working together. Think of the atmosphere as a superhero with many powers. First power, it provides the air we breathe. About 21% oxygen in the troposphere, the Goldilocks amount. Every breath you take is a gift. Next, a planetary thermostat. It acts like a giant invisible blanket. Day blocks some of the sun's intense heat. Night traps the Earth's warmth. That temperature regulation is crucial. Without it, day-night extremes would break ecosystems in tech. Power as a shield. Ozone layer blocks UV. Mesosphere burns up meteors. Magnetic field and thermosphere create auroras and block energetic particles. The atmosphere protects us from space dangers. Silent, tireless guardian. Critical part of the water cycle. Sun evaporates water from oceans, lakes, and rivers. Troposphere carries water vapor around the planet. Vapor condenses into clouds. Clouds release rain or snow, replenishing fresh water. Without this transport, land would be dry and barren. It connects the planet, distributing water far and wide. Breathing, warmth, protection, water. Our atmosphere is the ultimate superhero, no cape needed. This gigantic blanket of air protects and sustains all life on our beautiful blue planet. So, what can we do? How can we, as individuals, help protect this amazing, life-giving atmosphere? It might seem like a huge problem, but big changes are made up of millions of small actions. Your mission, should you choose to accept it, starts today. One of the best things you can do is to save energy. When we use less electricity, power plants have to burn less fossil fuel. This means fewer greenhouse gases and less pollution go into the air. Turning off the lights when you leave a room, unplugging electronics you're not using. Another powerful action is to think about how we get around. Transportation is a big source of air pollution. Try walking, riding a bicycle, using buses and trains. These choices add up to less traffic and cleaner air. Talk to your family about combining trips to the store. Every car trip not taken is a small victory for our sky. Planting trees is another wonderful way to help our atmosphere. Trees are nature's air purifiers. They breathe in carbon dioxide and they breathe out oxygen. Planting a tree is a gift to the future. It provides shade, creates a home for birds and insects, and actively cleans the air for years to come. Your most important tools are your voice and your brain. Learn about our planet and our atmosphere. Talk to your friends, family, and teachers. Encourage others to make small changes with you. When we work together, a planet-sized team, we can make a huge impact. Protecting our atmosphere is everyone's mission. Our air blanket protects us every day. It's our job to protect it back. Let's get to it.